the other big story that I'm sure you all saw in the news. If you didn't, you probably saw this Google Doodle there was a system of 7, count them, 7 planets. Oh, yes, whoever said that, 7 dwarfs, yes. Oh, but what was it from Snow White?
It was them taking a bath.
It is them taking a bath. Good call. So this little doodle has all the planets looking and waving at Earth, who's looking through a telescope. That, of course, so that, of course, is not how we found those planets. In fact, the planets do not come in and wave and smile at us. They are seen in silhouette against their background star. And so when the planet that's in orbit passes in front of the star, it causes a dip. And depending on the size of the planet and how quickly it's moving across the planet, the dip is deeper if it's bigger and wider if it's taking a longer time. And if it's taking a longer time, it's farther away from the central star. So these are data that were taken by the Spitzer Space Telescope and also by an ESO, a European telescope, showing the star, TRAPPIST-1, and these little dips. You can sort of see them up here, the little dips every time, and you can measure them, see that they happen on periodic occurrences. And so there are 7 of them. The different sizes tell you how far away they are and how massive they are compared to their parent star. So here are the 7 planets. These are an artist's conception.
7 dwarfs.
Yes, but you know what? I think the second person gets a prize too. Because no, you didn't hear before, and I love the enthusiasm, and so we're all for it. Yay! So anyway, this is a purely artist conception, has nothing to do with what they really look like, but it's nice to imagine. So that's the TRAPPIST-1 system with these very imaginative names. We'll come back to that, B, C, D, E, F, G, and H. This shows not the sizes to scale, but the orbits to scale compared to the sun, or the central star. This is, again, shows the sizes of the orbit, the extent of the orbits. We knew about this system for a couple of years, but we only knew of 3 of the planets before. And what's exciting about all of this discovery and why it made big news this week is because we filled in 4 more in the center. And so it's a solar system of 7 Earth-like planets. And that's sort of like the closest to our own solar system that we've seen in a while. So if you look at these numbers up here, it's a lot of numbers. But the closest one takes only a day and a half to go around its parent star. And the most distant one takes about 20 days, that's me leaning, compared to Mercury, which is 87 days. So it's much closer. All 7 planets are inside the orbit of what Mercury is around the sun. Now, the sun, so this little sort of shows you this, they don't all line up on one side, but shows that they're all quite crowded, all the orbits are quite crowded. But the central star is not like our sun. The central star is a fair bit cooler and fainter. And did you want to make a comment about that?
Yeah, well, it's a very cool red dwarf. And the habitable zone will be much closer to the red dwarf than it is in our solar system. In fact, it's so close that these planets are probably tidally locked. They probably have the same face towards that star because they orbit so quickly. There might be some resonances. Maybe they go around twice for every 3 times they orbit, kind of like Mercury does. But in any case, it could cause some problems for the habitability.
So is a dwarf star a star?
Dwarf star is a star.
Yeah. So this habitable zone is sometimes referred to as the Goldilocks zone. So it's not too hot, not too cold. And in fact, 3 of the planets that have been discovered are in this star's habitable zone. So just because the star is so much cooler, the habitable zone is much closer than it is in our own solar system. So they're all crammed in there. 3 of them, maybe even 4 of them if you do the atmospheric chemistry just right. So what could those worlds be like? You would be able to see the other planets very clearly. In the sky, you'd look up, you'd see pretty sizable worlds out there, the other planets. And so it looks like a great tourist destination, of course. People want to study this system more.
Yeah, well, they're so close, you might be able to space sail from planet to planet in the course of a few weeks, kind of like we go on cruises here. And you go on cruises to a few different countries in the Mediterranean. Well, let's cruise to a few different exoplanets.
Yes, question.
Being that those planets are all so close, would the solar wind strip the planets of their atmosphere?
That is a great question. The stars like that are typically pretty active stars, meaning lots of storms and flares. So yes, there would be a lot of stellar wind, almost certainly, but we don't know if the planets have magnetic fields that will really hold the atmosphere tight like we have, protecting us from the solar wind. Did you have anything you wanted to add to that? Or?
No, also activity tends to die down with age in M dwarfs, so they're most active in the beginning of their lives. And I haven't seen an age for this star, so I'm not sure of its activity levels, but that might buy you a little something.
So this system, yes?
So red dwarf is going to have a very long lifetime, so you could get really advanced civilizations on here, right?
That's exactly where I was headed with this, because it's only 40 light years away. So maybe, they're thinking about coming to visit us. Maybe we should send a signal and say, hey, come on by, because maybe you have the better... But it all depends on whether they are a friendly system, or perhaps they're not so friendly. Thank you, Jeff. So, of course, this spread or caused a lot of stir on the internet about possible names for these. So, basically, anything that you can think of, 7. Yes, we have.
Planet Coaster's a great game.
Naming after the 7. Yeah, I know, that's a good one. And obviously, yeah. There they are. See, they get it, right? And the must-have Icy McIce face. So, yeah. So, of course, that begs the question, what is in a name?
Look at all those chickens!